The curve defined by y equals 3 cos pi x over 16, where x is between 0 and 4, as we can see on the graph, is shown below. Determine the volume of the solid generated when the area bounded by the x-axis and the curve is rotated 360 degrees about the x-axis, so we're rotating around the x. So that means that the volume would be pi times the integral from x equals 0 to x equals 4 of y squared dx. So that's going to give me pi times the integral from 0 to 4 of 9 cos squared pi x by 16. Now, we know that cos 2a is equal to 2 cos squared a, take away 1. So that tells me that cos squared a is cos 2a plus 1, all divided by 2. So I could take the 9 outside and the 2 from the bottom there. And then what we'll have, now this is a double angle, so we want double this. If you double that, you're going to get pi x over 8. And then we've got the plus 1. So now the integral is such that we can just integrate it. So cos goes to sine, so we're going to have sine pi x over 8. Now we have to divide by the differential of the inside, so we're dividing by pi over 8, which is the same as multiplying by 8 over pi. And then this one's just going to be x. Okay, so we have 9 pi over 2. Now using the top limit of 4, we'll have 8 over pi, and then 4 pi over 8 is pi by 2, so it'll be sine of pi by 2 plus 4, and both of those will be 0 if we substitute 0 in. So I've got 9 pi over 2, sine pi by 2 is 1, so times 8 over pi, and then we've got 9 pi over 2 times 4. So that goes with that, and the pi's will go, so that's just 9 times 4, which is 36, and then that will go with that, and then I've got plus 18 pi, and that will be cubic units.